constantly be going down and checking them. Weather observer, you don't have to do that. You bring them in. If they've got experience, they're going to be very good. They can look at a cloud and tell you how high the bases are. Most of them can. Your very good experienced observers can do that. So you got to give and take on both sides of it. Eventually, sometime down the road, I'm sure everything's going to get better with the sensors, and it'll probably go all sensors, I would think, eventually.
Do you think that there's something, you know, I've worked with a lot of meteorologists and stuff, and one thing that they say is that some meteorologists are just better at prediction than others, and I wonder if you have any thoughts about you know, what makes someone somehow better able to predict.
Well, I think a lot of it has to do with your experience of what you're doing. Of course, most of us here already have at least 5 years experience on the counter. That means we've actually been forecasting weather for that period of time. The more you do anything, you get better at it. If you're in the scientific areas of meteorology, you're just not doing that kind of thing. You're looking at numbers and doing climatology, you're not looking at forecasting. So there's where the big difference is, I think it is. And then just, you're right, some people just have a knack for it. They can sit down and look at some numbers and say, I think this is going to happen instead of what it's looking like. And that really does come probably more from experience, especially in Antarctica, where there's very limited people here, very limited forecasters that have really talked to that have done it.
Do you think that there's, I mean, one experience that I had is talking to people who are tornado hunters, and so they would go out and, you know, even though they've got all this great data, they'll go out and experience it in person. Do you think there's a value or information to be gained for a meteorologist to go out? I mean, here you are, rather than being in an office, you know, somewhere in Washington, D.C., you're here and living in Antarctica doing it. Do you think there's a benefit to being in the space and experiencing the weather physically?
Yeah, I think so. Yes, it's a beautiful place. It's great to come and see, for one, but you just don't get those nuances sometimes. Now, once you've done it a year or two, you know, easily you can go somewhere else and forecast the weather at different places. The models become a little bit better out on some of the areas away from McMurdo that don't have quite the topography. That makes it a little easier too, but you can't get away from that, actually coming down and seeing the wind blowing at one day 20 knots and nothing happens, and the next day it's 20 knots and the visibility is a quarter mile outside.
Something that's really unusual and kind of not your normal weather.
Yeah, exactly. You don't see those things sitting up in a chair up in you know, the United States. Charleston's where we do most of the forecasting for the remote facility, and you just don't see those kind of things. You don't. Cameras are getting better. We can have camera shots, which can help out too for those remote facilities. But overall, that first or second year, it would be nice to get that person down here so they can actually see the weather itself.
Okay. Let me just stop here and
not picked up nearly as easy.
I think that's probably one of the things is, you know, how it's kind of a matter of life and death, really, when you're dealing with the weather down here. And I mean, that's something you don't usually hear about.
Right.
I wonder if you have things to say about that.
Yeah, we can get into that. Oh, I didn't realize the light was on. Yeah, another big problem that we do have down here is communications. HF radio is one of the highways that we usually use to get in contact with the South Pole in different areas, and even sometimes the pilots. And they also have backups with Iridium satellite phones now in most of the aircraft, but they don't always work. They're not always perfect. And if your aircraft is coming in during bad weather and he has no idea that that's coming in, this could be a very high hazard area for them. Going into the South Pole, going into McMurdo, even coming from New Zealand back down to here, they have a PSR forecast, which is basically a point of safe return. If they get to that point and the weather's bad, they turn around and they go back because there's only one or two places they can land down here. So if we can't get a hold of them for some reason or another, this may be a requirement for them to turn around because they haven't heard anything about the weather, or they know it's already poor, and then they've not got some kind of communication backup. So communications is important. It can go down here in McMurdo, it can go down in New Zealand, it can go down in the United States. All three places could create some havoc here on the continent, and that's safety for the people flying the aircraft and the people who are on their aircraft. Very important to us.
Does that, does the activity happening in the ionosphere or something have something to do with communications? That was my understanding.
Yeah, occasionally we'll have problems with the sunspots or solar flares, and that will create havoc, especially with the HF, those type of capabilities. and they'll just lose their radios for a while. So we may have to back up with iridium or some other aspect.
But that's not something that you guys are able to monitor with the soundings or anything?
Well, there is a global place that does put out readings
Right.
on that, and we will get those from time to time, yeah, but we don't forecast that actually here, but we will let them know if there is a problem once we find out about it.
Cool. So, there's another thing I wanted to talk about with the community. Oh, yeah. So, it seems like weather-wise, the fact that you can have planes like during winter, right?
Mhm.
Have you ever wintered over?
No, I have not wintered over.
Uh-huh.
My wife wouldn't like that.
Oh, yeah. Because you're stuck here for what, like 5 months?
Yeah, good. From the end of February till August at least.
Mm.
Yeah.
And what is? Can you just describe for me the weather situation that makes it impossible for planes to be coming in and out? That's pretty unique, I guess, in the world. Huh?
Yes, one of the main problems, obviously, with the main aircraft that comes down here, which is the C-130, is it has temperature restrictions. And minus 50 degrees Celsius is its temperature restriction. And they have problems with hydraulics and other things. So they're very limited in that area, say if it's minus 50 to 52, very limited of what they can do and what they can't. Well, during the winter, a lot of times the temperature here is minus 40 to minus 50 in McMurdo. So it would be a problem to try to get an aircraft in here, say, in the middle of July or in June when it's real, real cold. Now, the C-17 aircraft have helped out a little bit with that because their aircraft are a little bit more equipped for some of the colder temperatures, and so they're able to get down here, say, in August, which is wind fly time frame. And they can come down with some colder temperatures. And a lot of times, again, here at McMurdo, we can get temperatures minus 40 on a basis during that time frame. So they're a little bit warmer, a little easier. But trying to get maybe to the South Pole might be even harder than that because their temperatures are definitely below minus 50, say in June, July, August.
So they're locked in too, even in wind fly.
Yes, definitely.
Wow.
Yeah, at this point. Now, different aircraft can do different things. It's getting a little bit better. Even some of our Twin Otter aircraft, the Baslers, they're capable to go down to minus 54, I believe it is, and so they can get in a little bit easier than the the C-130s and then the C-17s.
Can you tell me a little bit about? You mentioned that you've had 20 years experience working and seeing things change. I mean, can you tell me a little bit more about kind of the things that you've seen change in forecasting?
Well, when I first started out, this would have been back in the early 80s, a long time ago, everything was teletype driven. It wasn't computer driven, it was teletype driven. We got all our information pumped into a machine that punched it out on a teletype. Maps were burned on an actual piece of paper that came out of an equipment that was done sometimes over the radio, and there were lines that were sent in for each of those. I think by the late 80s, we were starting to get pretty much all computerized by that point. And by the time we got into the mid-90s, everything was computerized. Didn't matter what it was, and almost everywhere you went. Even if you were, for instance, I have a military background, I was a Marine. When we went to the field, we still had computers there, and we still did everything that way via some type of computer to get a satellite picture, some type of computer to get your forecast information, and some type of computer to get your observations from your observers who were out there.
Mm-hmm. And how did the pictures change your whole kind of perspective on being someone who's trying to figure out what's happening?
Mm-hmm. Well, the picture itself, of course, this is an infrared shot, and the picture itself just gives me a good snapshot of what's actually going on out there at that time. It can tell me various things from the bright white areas are your higher clouds to the darker areas, which you can see in here, which are generally your lower clouds. That's on your infrared shot. And of course, if I didn't have this satellite shot, I wouldn't be able to see what's going on out there. The sensors would be able to tell me wind directions and temperatures. Some of them might be able to tell me a base of a cloud that's out there. But without this picture, I could do an entire forecast with this satellite picture, but without it, it makes it much, much harder to rely on a model that may be 6 hours off this direction or 12 hours off in that direction. This satellite picture helps me enhance that forecast even better. If I see something moving through the area, say at 15 Zulu, when I look at the satellite picture, I may actually see the timing is more like 18 or 19 Zulu. Well, that 4 hours may make a difference between an aircraft getting in here or not getting in here. So we can do an entire forecast off of this. It may not be the greatest, but we can do a really good forecast off of this, where when we look just at the models without that, it becomes much harder to